Foot and mouth disease is a badly misunderstood disease. It is one of the most feared animal diseases in the developed world. Yet it rarely kills animals, and humans cannot get foot and mouth disease. Foot and mouth disease is rather an economic disease, because in places where livestock are farmed intensively, it can spread quickly, also across borders, and has major impact on trade. In southern Africa, though, foot and mouth disease is usually a mild disease. It rarely kills cattle and usually spreads slowly. The viruses here are different from those found in other parts of the world. The goal of international health and trade organizations is to eradicate foot and mouth disease from livestock globally by 2020. But foot and mouth disease will not and cannot be eradicated from southern Africa because it is maintained and spread by wildlife. Kevin Lokokoto shouldn't be poor. After all, he has a large head of organically raised, free-range cattle. There must surely be a lucrative market into which Kevin could sell his sought-after animal products. But sadly, up to now, he cannot sell his beef to high-value export markets because international trade standards do not take the Southern African foot and mouth disease situation into account. African governments, including the Namibian government, desire to empower small-scale farmers like Kevin. If Kevin could become part of the export chain, it would change his life remarkably. According to current international trade standards, Kevin raises his cattle in a foot and mouth disease infected zone. And therefore, he cannot sell his beef to the international market. But Kevin will always raise his cattle in a so-called infected zone because he lives in a conservation area where buffalo maintain SAT serotypes of foot and mouth disease virus. Almost all outbreaks of foot and mouth disease in southern Africa can be traced to buffalo. The SAT serotypes evolved in and are maintained by African buffalo. These viruses have little, if any, effect on the buffalo themselves. But buffalo can and do transmit these viruses to other cloven-hooved animals, including cattle, sheep, goats, and antelope. This is the difference. In Africa, foot and mouth disease viruses evolved in African buffalo, the SAT serotypes. In Eurasia, foot and mouth disease viruses evolved in domestic livestock, the O, A, and Asia 1 serotypes. It is one thing to eradicate Eurasian serotypes of foot and mouth disease virus from livestock, but impossible with currently available technology to eradicate SAT serotypes from free-living buffalo populations. Vaccination of large numbers of wild buffalo would be neither practical nor effective. Also, the manufacture of vaccines against SAT serotype viruses is more difficult than for the Eurasian serotypes because SATs have many more variants. For that reason, available vaccines do not cover against all SAT viruses in different parts of southern Africa. Farmers like Kevin understand that foot and mouth disease comes from buffalo, but they can do very little to prevent an outbreak. They are communal farmers, and here are no fences. All cattle are free to range in order to access available grazing and water. Buffalo are also free-ranging, and their movement cannot be controlled. Many think that the transmission of foot and mouth disease viruses from buffalo to cattle occurs via contaminated grazing or drinking water. But the infection rarely spreads that way. Cattle and buffalo, like all ruminants, are usually infected by breathing in virus-containing aerosols produced by nearby diseased animals. In Northern Europe, long-distance transmission occurs over distances of 10 kilometers or more. But this does not happen in tropical or subtropical regions, mainly because of climate and low stocking density. Pigs usually become infected by eating foot and mouth disease virus contaminated swill. Infected pigs are extremely efficient transmitters of foot and mouth disease and readily infect other animals in the vicinity. In Eurasia, pigs are important in the spreading and maintenance of foot and mouth disease. But this is not the case in southern Africa. Here, free-ranging pigs are few, and they are seldom fed swill-containing meat. Kevin knows that outbreaks are unpredictable. Sometimes cattle and buffalo graze together without any foot and mouth disease occurring, while at other times, outbreaks of foot and mouth disease in cattle occur frequently. When buffalo calves are born, they are not infected with foot and mouth disease viruses. Initially, the colostrum they receive from their mothers in the first few hours after birth protects them against infection. But when the colostral antibodies wane some months after birth, calves become infected. The first one probably by an adult carrier in the herd. Once that happens, infected calves rapidly infect each other. Like children in a creche, this results in calfhood epidemics. The calves excrete large quantities of SAT viruses for a week or so, although they show no signs of the disease. Most calves in the herd thus become infected more or less simultaneously. It is during these times that breeding herds are potent sources of foot and mouth disease viruses, especially for cattle that are close by. Cattle are highly susceptible to infection with foot and mouth disease viruses, more so than other livestock species. These buffalo breeding herds show no signs when they are highly infectious, and not even scientists can predict exactly when that will occur. Kevin therefore does not know when to keep his cattle away from buffalo. After a calfhood epidemic in a buffalo herd, the virus disappears within a month from about half the calves. In the other half, the virus persists in the lining of the throat for many months or even years. These animals are referred to as carriers. Buffalo carriers sometimes transmit SAT viruses to other buffalo, and even more rarely to cattle. But the mechanism of this transmission is not well understood. It is known that transmission from buffalo carriers to cattle requires close contact between the cattle and buffalo for a long period of time, months or even years. So, it is unlikely that buffalo carriers are able to transmit the virus during brief contact with cattle. It is rather the breeding herds during calfhood epidemics that are the major risk to cattle, and not adult buffalo. Kevin can't understand why there is such hysteria about foot and mouth disease. Foot and mouth disease rarely kills cattle. His forefathers lived happily with foot and mouth disease for millennia. These farmers know the signs. On close inspection, they find raw erosions on the tongues and upper gums of some animals. There are also sores on the skin-hoof junction of their feet. The cattle will be uncomfortable for a few days, and the production of milk will be down. But after 3 weeks, there will be no sign of the sores, and the cattle will be perfectly healthy again. Milk will be produced as normal, and the cattle will breed and have calves as if nothing had happened. Foot and mouth disease also does not infect people. Nobody in the community will get sick, even if they were to drink the milk of infected cows, which contains very high levels of virus. Here, it makes no sense to stamp out the infected cattle because the figurative medicine would be worse than the disease. After the lesions have healed, about half of the cattle will no longer show any traces of the virus. In the other half, the virus persists, as in buffalo, in the lining of the throat for up to 6 months and in some even longer. Yet extensive investigation has shown that these persistently infected cattle, also termed carriers, are not able to transmit the infection to other cattle. This is a major difference between buffalo and cattle carriers. Buffalo carriers can transmit the infection, although only inefficiently. Persistently infected cattle have been shown by decades of research work to be incapable of such transmission. Because Kevin farms in this high-risk area, he and the other farmers in his community are obliged by the government to have their cattle vaccinated against foot and mouth disease 3 times a year. They comply readily. Current foot and mouth disease vaccines are effective in reducing the incidence of disease, but cannot absolutely prevent infection, mainly because there are so many variants of SAT viruses maintained by buffalo. Irregular flooding is also a problem in these areas, and often not all cattle can be vaccinated at every vaccination session. Kevin is further confronted by foot and mouth disease virus circulation in antelope as well as buffalo. Here, buffalo come onto the Chobe floodplain mostly at night. Kevin and other farmers kraal their cattle at night to protect them from predators, and this helps to reduce direct contact between buffalo and cattle. But during the dry winter months, there are many wild ruminants on the floodplain, day and night. Antelope like impala and waterbug. They are a potential intermediary in the transmission of foot and mouth disease viruses between buffalo and cattle. Impala, for example, have been shown to be highly susceptible to low doses of SAT viruses and are able to infect cattle. Impala can become diseased but often show no signs of infection. Antelope, unlike buffalo and cattle, are not able to maintain SAT viruses independently. Here, buffalo herds and other wildlife move freely between 5 different countries. Informal cattle trade across borders also happens in some locations and is very difficult to prevent. Wildlife conservation through the creation of trans-frontier conservation areas has become a priority in southern Africa. Buffalo are one of the Big Five, the biggest draw card for international tourists. Kevin and his community are passionate conservationists. They signed up to all the measures necessary to protect their precious environment and form their own conservancy. The Kaza Transfrontier Conservation Area is the largest in Africa and vital for future wildlife conservation in a huge area, about the size of France. Kevin also manages the community's game guards. They patrol many kilometers every week in an effort to protect the wildlife in their conservancy. The game is precious to them, as tourists from all over the world visit this area to experience the wildlife spectacle. The community are co-owners in some of the lodges that accommodate tourists, and they also earn an income from hunting quotas. Conventional control measures used in southern Africa require that infected wildlife and cattle be separated by fencing systems. But a major objective of trans-frontier parks is to remove barriers between countries in order to restore wildlife migration routes. A number of countries in southern Africa use fences to separate wildlife and livestock populations, to maintain foot-and-mouth disease-free zones. But these fences have had devastating effects on wildlife. Small-scale farmers in the Zambezi region cannot part with their cattle. When Kevin needs money for his family, he sells some of his cattle. His cattle are the only valuable commodity he has to trade. His salary from his wildlife conservation work is too meager to support his extended family. Income from tourism is seasonal and shared by the whole community. It is simply not enough to provide for all the families that live in the area. Cattle raising in rural areas of southern Africa is part of the people's culture and way of life. But science offers new options. Kevin can produce safe beef, even though he raises his cattle in an area where foot-and-mouth disease viruses are present in wildlife. The Namibian government has embarked on an extensive program to empower small-scale farmers like Kevin. They have turned their focus to the safety of the beef itself. Farmers are encouraged to improve the quality and productivity of their cattle. A mentorship program has been introduced to inform farmers on better husbandry practices. It is important to produce younger, heavier and better conditioned cattle for slaughter, because Meatco pays accordingly. When Kevin's beef is processed at the abattoir by Meatco, it is matured until it reaches a pH of less than 6. Bones and lymph nodes are also removed from the meat. The scientific research team working on this project has confirmed that beef processed in this way cannot transmit foot and mouth disease. They showed that no foot and mouth disease virus is present in muscle or fat of cattle experimentally infected with SAT viruses. All other internationally prescribed food safety measures are implemented as well, exactly as is the case for all other export food products, to ensure that the beef is safe for human consumption. The value chain approach involves combining commodity-based trade and HACCP methodologies to manage all sanitary risks along the value chain. An independent risk assessment confirmed that beef produced this way complies with international sanitary standards. We should rather concentrate on the process of producing safe beef and not on the region where cattle come from. Then we could help Kevin and thousands of other farmers to improve their income and at the same time conserve our priceless wildlife heritage. A scientific solution to the man-made plague is available.